Welcome, class, to the Intro to Java Programming. This is the fifth of 6 lessons on operators. Today we will review bitwise operators along with code examples. We will also cover bitwise assignment operators. Operators are used to perform operations on variables and values. Those operations can be in the form of expressions or conditions. Expressions can produce a value, assign a value, and possibly do nothing, like in the case of a void method call. In this lesson, we will focus on an expression producing a value in the form of a bitwise equation. A condition is used in a decision process to determine if the evaluation of two expressions are true or false. One example could be, is 3 greater than 2? This is a true condition. Use of bitwise operators applies to whole numbers like byte, short, int, and long. Let's go over the 7 bitwise operators. One ampersand symbol is used to represent an AND. One pipe symbol is used to represent an OR. The pipe symbol is typically found on the backslash key above the return. One caret symbol is used to represent an exclusive OR. The caret symbol is typically found on the number 6 key. One tilde symbol is used to represent a not or a complement. The tilde key is typically found left of the number 1 key. 2 less than symbols are used to represent a zero fill left shift. 2 greater than symbols are used to represent a signed right shift. And 3 greater than symbols are used to represent a zero fill right shift. Bitwise operators are typically the least used operators but are important to understand. As you see with the list of operator symbols, the bitwise AND is 1 ampersand, the logical AND is 2 ampersands. It is a common mistake to code a logical AND with 1 ampersand instead of 2, and it is not a compiler error and it may be very difficult to detect this mistake. Also, during the job interview process, there may be a question that tests your ability to detect an incorrect use of a bitwise operator where a logical operator is expected. To help understand bitwise operators, we first need to understand a bit. Let's go over how bits in a byte work. 1 byte of data holds 8 bits. These bits are either 0 or 1. There are 256 possible combinations of zeros and ones, which is why 1 byte of data can hold a value from 0 to 255. The bits of a byte are read from right to left. Consider these positions as 0 to 7. The values of the positions is calculated by 2 to the power of the position. Here we calculate 2 to the power of 0, which is equal to 1. If this bit is on or set to 1, this value is 1. In position 1, the value is calculated by 2 to the power of 1, or 2. If this bit is on or set to 1, the value is 2. Since this bit is 0, the value is 0. We perform the same calculation on each bit position. Then we add all the values together and you will have the final value of this byte of data. In this example, it is 73. It is helpful if you can convert from decimal to binary and binary to decimal, but is not required. Most of you should have a calculator that can convert the value in either direction. The main reason for showing you the binary values is because these bits are like Boolean values. They are either 0 or 1. You could also say that each bit is false or true. Time for a Coach Joe challenge question. If you recall from lesson 19, what is tested by a logical operator? Yes, 2 conditions are tested. And what is the result of the logical condition? Correct. The logical operator is testing 2 conditions. These conditions can be true or false. There is a logical AND with a matrix that is used to determine the result, which can be true or false. Now let's change the display of this logical condition. Let's put one condition above the other. Let's place the logical AND off to the right, and let's draw a line to represent the result below that line. Notice that this result is false. The bitwise operator is doing the same thing with bits instead of conditions. Here we have a bit value. Let's say it's 1. We can have another bit value. Let's say it's 0. The bitwise AND is 1 ampersand. We can use the same matrix by using true equals 1 and false equals 0 to come up with the result of 0. The logical and bitwise ANDs are similar, but the result is different. The result of a logical operator is a condition. The result of a bitwise operator is an expression. Let me explain. The bitwise operators will work with bits of a byte. Take this example, 7. It is represented like this in binary. For the second value, let's use 10. It's represented like this in binary. And let's perform a bitwise AND. I'm adding a column separator between each bit. Starting from the left, this bit is 0, and this bit is 0. The result is 0. The same is true for the next 3 columns. The result of 0 and 1 is 0. The result of 1 and 0 is 0. The result of 1 and 1 is 1, and the result of 1 and 0 is 0. The final answer is 0, 0, 0, 0, 0, 0, 1, 0, or 2. So if I had a statement like result equals 7 and 10, the answer would be 2. We will test this in code later. The result of a bitwise operator is an expression. It's not like an addition or multiplication expression, but more about manipulating the bits of a byte. As you can see with this example, all the bits that are 1 for both values will be 1 in the result. If we change the bitwise AND to a bitwise OR and use the OR matrix, these columns have 0 for both values. The result is 0. These columns have a 1 in either value. The result is 1. The result of this bitwise expression is 0, 0, 0, 0, 1, 1, 1, 1, or 15. There is a bitwise exclusive OR. Here's the exclusive OR matrix. We will be looking for only one of the values to have a bit set to 1. If so, then the resulting bit is 1. If both bits are the same, the resulting bit is 0. The result of this bitwise expression is 0, 0, 0, 0, 1, 1, 0, 1, or 13. If you recall the addition assignment operator from lesson 17, there is a long way and a short way to add values to an existing variable. Each of these bitwise operators has a matching assignment operator. Ampersand equal sign will perform a bitwise AND and assign the result to itself. Pipe equal sign will perform a bitwise OR and assign the result to itself. Caret or shift 6 with an equal sign will perform a bitwise exclusive OR and assign the result to itself. I'll show you a few examples in code after we cover the 4 remaining operators. The next operators are used to alter one specific value. The bitwise NOT or complement will switch the values for each bit. If the bit is 0, the result is 1. All of these bits will also be 1. If the bit is 1, the result is 0. The result of this expression is 1, 1, 1, 1, 1, 1, 0, 1, or negative 3. If this bit is 1, the value is negative. You will need to do additional research to learn how negative numbers are displayed in binary. Another way to alter the bits of a byte is by shifting the bits to the left or the right. Imagine we have the value 0000, 1010, which is the number 10. If we shift the bits 1 to the left, the result is 0001, 0100, or 20. It is important to note that the rightmost bit is filled with the 0. Here is the left shift assignment command. 2 less than symbols are followed by an equal sign is a left shift. The number after the equal sign is the number of positions that will be shifted. If you have this byte value, 0100, 0000, which is the number 64, shifting the bits 1 to the left will be 1000, 0000, or negative 128. Remember, the leftmost bit is used to represent a negative number. There are 2 right shift operators. This command will shift all the bits 1 position to the right. A copy of the leftmost bit will be placed as a new fill bit on the left, and the remaining bits will move 1 position to the right. The rightmost bit will fall off and disappear. Here, negative 128 will become negative 64. Notice a 1 was used as the new fill bit on the left. Here, 39 will become 19. Notice a 0 was used as the new fill bit on the left. This command will shift all the bits to the right except the sign bit. Here, negative 9 becomes negative 5. Notice that the leftmost bit did not shift, and this bit was filled by a 0. Here, 17 will become 8. There are some clever situations for a bitwise operator, but this will be a crude and older example that may help you understand some uses. Imagine you are displaying graphics on the screen for an old-time video game. Each box represents 1 pixel to be displayed. Each box is 1 bit of a byte. Let's say you want to draw this image. 1 byte has 8 bits or 8 boxes. This could be 1 graphical byte. The byte would look like this. The bits with a 1 will have the graphics pixel turned on. The bits with the 0 will have the graphics pixels turned off. Imagine I need to display another graphic of a dot right here. This byte of data is in the same byte as the portion of the main character. Here is the value of that dot. To prevent one value overwriting the other value, we could use a bitwise OR. This will allow both bits to be displayed in the same byte. You could also imagine that the left shift or right shift could simulate motion in our graphics character. As I mentioned in the beginning of this lesson, the bitwise operators are the least used of the operators. I found it more important to spend time showing you how they worked visually than with code. Let's go to our basics project in IntelliJ, close any open class tabs. Let's create a new class called Bitwise Test. To save some time, I'll show the code summary for all the earlier examples. Feel free to edit or run these tests to see how these commands work on your own time. Let me run all these tests. They all pass. You should now have an understanding of the bitwise operators and the bitwise assignment operators. These operators are rarely used in code but are commonly mistaken when performing a logical operation. During the interview process, you may be asked questions about the bitwise operators, so it's important to understand the proper usage. In the next lesson, we'll discuss the if-else decision statement. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!